Hi, this is Matthew Dustin, and we are Group 116. The physics demonstration in which our group settled upon was dropping a ball from three various heights to observe how the ball behaves and bounces when it impacts the ground on various surfaces.
Hi, my name is Chris Brown. For this experiment, we measured the amount of energy lost when we dropped the ball and it bounced on the carpet and on the ground. The amount of energy is transferred. Part of it is transferred to heat and sound and things like that, and that's the reason why the ball doesn't come back up to the original height that it does when we start.
Hello, this is Brian Brito, and for this experiment we needed a ball, measuring tape. We used two different surfaces to see the different effects that it had on the ball when it bounced, and we also used a weight to measure the ball's weight.
Hi, I'm Chris Brown, and if there's one thing that we've learned during our time here at Full Sail is that nothing is done from memory. You need reference for everything that you do, and in the animation industry. So if you wanted to animate something as simple as a ball drop, you would first have to understand the dynamics of the ball, the fall, the impact, and the bounce. You would also need to take into account the weight and density level of the ball and what material it's made of. Other factors is what ground it's made out of and if it's level and how high the drop of the ball is.
In animation, it's extremely important that things look realistic. When a character drops a ball, you expect it to come back at a lower height than which he dropped it. When this doesn't happen, you get confused because the physics is wrong and scenes can fall apart. In this portion of the experiment, we dropped a ball from a height of 1 foot onto a hard surface. We repeated this step multiple times and measured the peak of the bounce each time. The bounce from a 1 foot drop onto a hard surface averaged about 9 inches. Next, we repeated these steps, but instead of dropping the ball from a height of 1 foot, we dropped the ball from a height of 3 feet onto the hard surface. The average height of these bounces was about 24 inches.
A little lower, there, solid. And then 24 is right here. That looks pretty good. All right, go.
Finally, we dropped the ball from a height of 6 feet onto the floor. These bounces averaged 45 inches. We used the potential energy equation, mass times gravity times height, to find the amount of energy stored before each drop. We used the same equation to find how much energy there was at the highest point of the bounce. Then we simply took the energy level before the drop minus the energy level at the highest point of the bounce to find the loss of the potential energy. This number tells us the amount of energy lost to things such as heat, sound, and air resistance, and explains why the ball doesn't continue to bounce back up to the original level. After this, we moved the ball to a carpeted location and again dropped it from 1 foot. The bounce was 7 inches. This is the drop from 3 feet onto the carpet. The peak of this bounce was 21 inches.
Yeah, it's about 21 now.
And finally, here's the drop from 6 feet onto the carpeted floor. The height of this bounce was 41 inches. We used the potential energy equation again and inserted the height of the bounces to find these energy levels. Again, we subtracted the potential energy of the bounce from the initial potential energy to find the amount of energy lost. Here's a quick comparison of our findings. As you can see, there's less energy lost to the hard surface than the carpet. This explains why a ball will bounce lower on a carpet than a hard surface.
In conclusion, physics plays a vital role in the animation industry because in order to mimic reality, one must understand the laws of physics and how they can be properly portrayed in motion pictures.
Physics.